Nature. It should not harm us. It should be highly soluble in water. It should be stable during storage. It should be assoluble in pure state and dry state in market or lab, etc. Example: oxalic acid crystal 224.22, mohair salt 227, etc. Secondary standard solution. That standard solution which concentration/strength estimated with the help of primary standard solution is called secondary standard solu. Tie-in/substance.
Or
4. Define endpoint, equivalent endpoint, indicators titration, molarity, normality. Endpoint equals that point or stage during titration at which reaction is complete indicated by indicator changing its own color is called endpoint. Equivalent endpoint equals it is defined as the 1 gram equivalent of 1 gram equivalent of another substance, i.e., base. Indicator equals that chemical substance which give information about the completive reaction during titration by changing its own color is called indicator. Molarity equals molarity. M is a unit of concentration defined as the number of moles of solute dissolved in 1 liter of total solution. Normality equals normality. N is a measure of concentration in chemistry, defined as the number of gram equivalents of solute per liter of solution. 5. Explain the limitation of Arrhenius concept acid base. Arrhenius acid. According to Arrhenius theory, an acid is a substance that dissociates to give hydrogen ions when dissolved in water. For example, when hydrogen chloride gas dissolves in water, it gives hydrogen ions. The release of hydrogen ions increases the concentration of hydrogen ions in solution and makes the solution acidic. Arrhenius base. According to Arrhenius, base is a substance that dissolves to give hydroxide ions when dissolved in water. For example, when sodium hydroxide dissolves in water, it releases hydroxide ion. Limitations of Arrhenius theory. 1. Arrhenius theory explains acids and bases in terms of their presence in aqueous solution and not as a substance. As such, the theory is limited to the study of acids and bases in aqueous solution only and not applicable in gaseous and non-aqueous solutions. 2. Arrhenius theory is applicable only to acids having the formula Ha. For example, HCl, HBr. It is not applicable for SO2, CO2, and AlCl3. 3. Arrhenius theory is only applicable to bases having the formula BOH. For example, NaOH, KOH. It is not applicable for Na2CO3 and H3 and pyridine. In fact, the need to prove the relationship between base and OH ion led to the proposal of the formula NH4OH as base of ammonia in water, the actual formula being NH3. 4. According to this theory, solvents do not play any role in deciding the nature of acids and bases. For example, hydrochloric acid is strong when dissolved in water, but it is weak when dissolved in benzene. 5. This theory fails to explain the properties of acids and bases in any solvents like benzene or acetone, or gases, other than water. 6. Define Bronsted and Lewis concept for acid and base. 7. Explain ionization constant of water and calculate. 8. State and explain Ostwald dilution law. ANS. Ostwald's dilution law states that the degree of dissociation of a weak electrolyte is inversely proportional to the square root of molar concentration or directly proportional to the square root of volume holding 1 mole of the solute for a weak electrolyte. Its mathematical formula is Ca equals A superscript 2C/1A. Ostwald used the law of mass action in ionic equilibrium, which is analogous to chemical equilibrium because ions are in equilibrium. He devised an equation for the fluctuation of an electrolyte's degree of ionization with dilution, which is known as Ostwald's dilution law. 9. Solubility product principle and buffer solution. ANS. Solubility product. The solubility product KSB is an equilibrium constant measuring the extent to which a sparingly soluble ionic compound dissolves in a saturated solution, calculated as the product of ion concentrations, each raised to its stoichiometric power. Solubility product principle. For given temperature soluble salt solution. Buffer solution. That solution which resists the change of pH due to addition of a small amount of acid or base is called buffer solution. E.g., 3 plus 3 for plus 4 types. 1. Acidic buffer solution. That buffer solution which pH value is less than 7 is XII. Deacidic buffer solution. It is prepared by mixing of weak acid and its salt of a strong base. 3 plus 3, 2. Basic buffer solution. That buffer solution which pH value is greater than 7 is called basic buffer solution. It is prepared by mixing weak base and its salt of strong acid. Mechanism of buffer solution. 10. Hydrolysis of
salt.
ANS, when salted dissolved in water to give corresponding acid and base, is called hydrolysis of salt. It is reverse reaction of acid and base / neutralization reaction. NaOH Na plus plus OH. Strong base, HCl H plus plus Cl. Strong acid, NaCl is neutral solution H plus ions furnished by acid. HCl is completely react with OH, ion furnished base, and AOH. So, NaCl is neutral salt. FeCl3 is acidic salt. H plus ions furnished by acid HCl is not completely react with OH, ion furnished base, FeOH3. So, FeCl3 is acidic salt. Fecal 3 plus 3H2O FeOH, 3 plus 3HCl. Weak base strong acid CH3COO and A is basic salt, OH, ions furnished by base, and AOH is not completely react with H plus ions furnished acid, CH3COOH. So, CH3COONA is basic salt. CH3COO and A plus H2O CH3COOH plus NaOH. Weak strong, 11. Fine pH and pOH ANS. 12. pH and pOH in aqueous medium using Kw value.
All.
pH plus Po equals 14. 13. Difference between order of reaction and molecularity of reaction.
All.
14. Define rate or reaction rate law, rate constant, factor affecting ROR, first and zero order or reaction ANS. Rate of RxN equals it is defined as the change in concentration of reactant or product with respect to time. Equals F. And which influences the rate of RxN is called rate law. Rate constant equals it is defined as the rate of chemical reaction when the concentration of each of reactant is unity, i.e. 1 mole, 1 L, 1, 0 ord.
Ord.
RxN equals the chemical reaction in which rate of reaction is independent upon the initial concentration of reactant is called zero-order reaction. First order RxN equals the chemical RxN in which rate of reaction is directly proportional to initial concentration of reactant is called first order RxN. Factor affecting rate of RxN equals the rate of a chemical reaction is primarily affected by temperature, reactant concentration, or pressure for gases, surface area, and the presence of a catalyst. 15. NERG. Y level diagram ANS. Activation energy. Activation complex theory diagram. 16. Rate law numerical.
All.
17. Define thermodynamic. ANS. Thermodynamics is the branch of science that studies the relationships between heat, work, temperature, and energy. In chemistry, chemical thermodynamics specifically focuses on the energy changes associated with chemical reactions and physical changes. 18. State first and second law of thermodynamics. ANS. First law of thermodynamics. Second law of thermodynamics. It defines the entropy of system. Entropy defines the randomness disorderness as well as unavailable energy of the system. Asterisk entropy of system increases. That is, entropy must be maximum for the spontaneous process. Asterisk spontaneous process occurs naturally and irreversibly. Thermodynamics efficiency of heat engine is always less than unity. 19. Explain enthalpy and enthalpy change in various process. ANS. The total heat contained in the system of constant pressure is called enthalpy of system. It is represented by H. It is also a state function, so absolute value of enthalpy cannot be determined. It can be calculated in the form of change in enthalpy, i.e. H equals E plus PV, where H equals enthalpy in system, E equals internal energy of system, P equals pressure, V equals volume. From first law of thermodynamics, Q equals E plus QV. Q equals increment plus increment. In the RxN carried out at constant pressure, QP sad face EPR plus PVP PVR equals EPR plus P VP VR equals EP plus PVPR PVR equals HPHR. QP equals increment. It means change in enthalpy is equal to the total heat contained in a system at constant pressure. 20. Different between endothermic and exothermic process with the help of energy profile diagram and 21. Gibbs free energy.
All.
The amount of energy used for doing useful work is called free energy or Gibbs free energy. It may also be defined as the enthalpy and entropy of a system at constant temperature. It is represented by G, i.e. G equals H plus Ts. Where H equals enthalpy, T equals absolute scale of temp of surrounding, S equals entropy of system. In above equation, I, H, T, and S be the state function, so G is also state function and calculate in the form of change of Gibbs free energy. Now, at initial state, H1, G1, S1, G1 equals H1, TS1. 2. At final state, H2, G2, S2, at constant temper. G equals H2, TS2 change in Gibbs free energy G1, G2 equals H2, TS1 dash H1, TS1 increment equals 2 minus 1 minus 2 plus 1 increment equals 2 minus 1 minus 2 minus 1 increment. L developed between electrode and electrolyte solution due to separation of layer on the surface of electrolyte solution at a standard condition at 25 degrees Celsius and 1 atm pressure is called standard electrode potential. 23. Application of electro. Electro. Chemicals series.
All.
24. Relation between cell potential and free energy, Gibbs free energy. Free energy.
All.
25. Numerical based on electrochemistry.
All.
26. Characteristics of transition metal.
All.
26. Extraction of Cu.
All.
5. Purification. The impure Cu is purified by electro-refining process. In this process, the impure Cu is made SA anode, and a thin sheet of pure Cu is made as cathode containing acidified copper sulfate as electrolyte on passing electrolyte impure Cu dissive and pure CuId deposited at cathode. 27. Extraction of Zn.
All.
28. Extraction of Hg.
All.
1. Concentration. The ore is crushed powder and the concentrated by fourth flotation. 2. Roasting. The concentrated ore is mixed with coke and charged in a shaft furnace coke burns and ore is heated in air at 500-600 C. 3. Purification. The mercury obtained above is 99.7% pure and contain Pb, Zn, and Sn as impurities. It is purified from the impurities by treating it treated with DIL. HNO3. Hg plus HNO3 Hg2, NO3, 2 plus NO plus H2 O Pb plus Hg2, NO3, 2 Pb, NO3, 2 plus Hg značka plus Hg2, NO3, 2 značka, NO3, 2 plus Hg SN plus Hg2, NO3, 2 SN, NO3, 2 plus Hg. 29. Extraction of iron.
O,
30. Extraction of steel.
O,
31. Chemistry of blue vitriol, QSO 4.5 H2O.
O,
32. Chemistry of white vitriol, ZnSO 4.7 H2O.
O,
33. Chemistry of calomel, Hg2Cl2.
O, O,
35. Chemistry of corrosive sublimate, mercuric chloride.
O,
36. Separation of 10, 20, and 30 alcohol by Victor Meyer's method.
O,
The following process is separate 10, 20, and 30 alcohol. 37. Separation of 10, 20, and 30 amine by Hoffman's method.
O,
The following process is separate 10, 20, and 30 amine. 38. Name RxN. ANS, aldol condensation, Cannizzaro RxN, Perkins condensation. Claisen condensation, benzoin condension. Carbylamine RxN, Reimer-Tiemann RxN. Diazotization RxN. Friedel-Crafts. Hoffman's bromide. Esterification. Carbonylation RxN. Williamson's synthesis. Rosenmund reduction. Coupling RxN C6H5 and 2 plus Cl minus plus C6H5OH C6H5 and equals N C6H4OH. 39. Test RxN ANS iodoform test when iodine and sodium hydroxide are added to a compound that contains either a methyl ketone or a secondary alcohol with a methyl group in the alpha position. A pale yellow precipitate of iodoform or triiodomethane is formed. It can be used to identify aldehydes or ketones. If an aldehyde gives a positive iodoform test, then it must be acetaldehyde since it is the only aldehyde with a CH3C equals O group. Given below are a few example reactions for positive iodoform tests. Silver mirror test. Tollens test is a very useful method to distinguish between aldehydes and ketones. This qualitative lab test is also referred to as the silver mirror test. Ogno 3 plus NH4OH AgOH plus NH4NO 3 AgOH plus NH4 OHAG and H3 2OH plus H2O. When aldehyde is warmed with Tollens reagent, it gets reduced to metallic silver, which is deposits on the inner wall of the test tube and gives silver mirror, so this reaction is called silver mirror test. CH3, CHO plus Ag, and H3. 2OHCH, 3 Kun 3 plus Ag plus NH3 plus H2O nitrous acid test of 10, 20, and 30 amine. 4. DNP. 4. DNP derivatives offer a convenient way of separating the components of a mixture of aldehydes and ketones. Rather than attempting to do this directly by fractional distillation, a chemist might take advantage first of the easy separation of 4 DNP derivatives by column chromatography. Since their formation from aldehydes and ketones is reversible, hydrolysis of the separated derivatives will then regenerate the original carbonyl compounds. Preparation of chloroform.
O,
41. DDT, BHC, bakelite, TNT, chloropicrin, phenolphthalein, picric acid, urotropin. Bakelite. Bakelite. Picric acid. acid. 42. Conversion. A1. Bromopropane to 2-bromopropane ANS. 1-bromopropane reacts with alcoholic KOH, or NaOH, to undergo beta elimination, forming propene, potassium bromide, and water. Then, propene reacts with hydrogen bromide, HBr. According to Markovnikov's rule, the negative part, Br, attaches to the carbon with fewer hydrogen atoms, the secondary carbon. B1. Propanol to 2-propanol. ANS. 1-propanol is treated with concentrated sulfuric acid, H2SO4, and heated to remove a water molecule and form propene in alkene. Then the propene is then treated with water in the presence of an acid catalyst. According to Markovnikov's rule, the hydroxyl group, OH, attaches to the second carbon less hydrogen, producing 2-propanol. C. Phenol to anisole, methoxybenzene. ANS. Phenol is treated with a strong base, typically sodium hydroxide, NaOH, to form sodium phenoxide, which is a better nucleophile than phenol itself. Then, the sodium phenoxide reacts with a methylating agent, such as methyl iodide, CH3I, or dimethyl sulfate, CH3,2SO4, via an SN2 reaction mechanism. D. Ethoxyethane to methoxyethane. ANS. The ether is reacted with cold HI to break 1C=O bond, resulting in ethanol. Then, ethanol is treated with sodium to produce sodium ethoxide. At last, sodium ethoxide is reacted with methyl iodide, or methanol in the presence of strong acid, to form methoxyethane, ethyl methyl ether. E. Aniline to azo-di-ANS. Aniline reacts with nitrous acid at low temperature, 0 to 5 degrees Celsius. Benzene diazonium chloride is obtained. Then benzene diazonium chloride reacts with an activated aromatic compound like phenol or aniline in alkaline medium to give azo-di. F. Phenol to toluene ANS. Phenol is heated with zinc dust to produce benzene. The zinc removes the oxygen from the hydroxyl group, forming zinc oxide. Then, benzene is treated with methyl chloride, CH3Cl, in the presence of anhydrous aluminium chloride, AlCl3, to give toluene, which acts as a Lewis acid catalyst to introduce a methyl group. G. Methanamide to ethanamide ANS. Methanamide is heated in presence of P2O5 to give HCN. Then, HCN is react with a methyl halide, like CH3Cl, to give ethanenitrile, acetonitrile. And ethanenitrile is hydrolysis to give ethanamide. 43. A. Why is chloroform stored in a dark bottle containing ethanol ANS? B. Why does chloroform not give white PPT with aqueous AgNO3 ANS? Chloroform does not ionize to give free Cl ions in aqueous solution because the C-Cl bonds are covalent and not easily broken. Since AgNO3 gives a white precipitate, AgCl, only with free chloride ions, no precipitate is formed. C. Why is boiling point of ethanol greater than that of ethoxyethane ANS? Ethanol forms strong intermolecular hydrogen bonding due to the hydroxy group. Ethoxyethane, ether, lacks OH hydrogen, so it cannot form hydrogen bonds, only weak van der Waals forces. D. Why does nitrobenzene undergoes electrophilic substitution reaction at meta position? Explain why an O2 group is meta directing toward electro-aromatic substitution. ANS, the NO2 group is a strong electron withdrawing group due to I effect, inductive withdrawal, R effect, resonance withdrawal. This decreases electron density at ortho and para positions, making them less reactive at N resonance structures. Positive charge appears at ortho and para positions, making them unstable for electrophilic attack. The meta position remains relatively less deactivated, so substitution occurs there. 44. Right monomer and one uses a nylon 6,6-ANS monomers, hexamethylenidiamine H2N, CH2, 6, NH2, adipic acid HOC, CH2, 4, COH. It is used in making strong synthetic fibers for textiles, e.g., ropes, fabrics, tire cords. B. Polyvinyl chloride, PVC, ANS, monomer. Vinyl chloride, CH2 equals CHCl. It is used for making water pipes and electrical cable insulation. C. Teflor, PTEF, ANS, monomer. Tetrafluoroethylene. It is used as non-stick coating on cookware, pans, utensils. D. Polystyrene ANS, monomer. Styrene. It is used for making thermocol, packaging material, and insulation. E. Bakelite ANS, monomers. Phenol plus formaldehyde. It is used for making electrical switches and sockets, insulators. 45. Right example and one use of. A. Analgesic ANS, aspirin, used for pain, fever, and sometimes for heart health. B. Antipyretic ANS, paracetamol, used to reduce high body temperature, fever, and relieve mild pain. C. Antibiotic ANS, penicillin, used to treat bacterial infections, such as strep throat or pneumonia, by killing or inhibiting bacteria. D. Tranquilizer ANS, diazepam, Valium, used to treat anxiety, tension, or as a sedative to induce calming effects and sleep. E. Antiseptic drug ANS, povidone iodine, betadine, or chlorhexidine gluconate use, applied topically to living tissue, skin, mucous membranes, to prevent infection by killing or inhibiting bacteria, fungi, and viruses, such as cleaning skin before surgery or treating minor cuts. F. Herbicide and pesticide ANS, glyphosate use, applied to agricultural crops or landscapes to control weeds, unwanted plants that compete for nutrients, sunlight, and water. G. Germicide and insecticide ANS. Germicide, isopropyl alcohol used as a topical skin antiseptic or to disinfect surfaces by disrupting the membranes and proteins of microorganisms, bacteria, viruses, fungi. Insecticide, pyrethrins used as applied to crops or household areas to kill or control insect populations, e.g., mosquitoes, beetles, cockroaches. H. Natural and synthetic dye ANS, natural dye. Indigo, Indigofera tinctoria, used for. It is a plant-based dye primarily used for producing deep blue shades on natural fibers like cotton, silk, and wool. It is famously used to dye denim fabric. Synthetic dye, reactive dyes used for. Used for intense, color-fast dyeing of cellulosic fibers such as cotton, viscose, and linen. 46. Right flowsheet diagram of the production of cement.
All.
47. Right flowsheet diagram of production of paper and pulp.
All.
48. Difference between OPC and PPC cement.
All.
49. Difference between nuclear fusion and fission RXN.
All.
50. Raw material of A. Paper and pulp ANS, softwood, hardwood, grasses and reeds, agricultural residues, recycle materials, pulping agents, bleaching agents, fillers, etc. B. Cement. I. Calcareous material, which supply limestone, chalk, clay, shales, waste, calcium carbonate. 2. Argillaceous material, which supplies silica clay, shoals, ashes, biased furniture slag. 3. Gypsum, Caso 4.2H2O to slow down the seething process of cement. 51. Reasonable questions. A. Cu++ complex are colored while those Zn++ are colorless explains the reason. ANS, Cu superscript 2 has an incomplete d subshell, 3D, so d electronic transitions are possible when light is absorbed, producing color. And Zn superscript 2 has a completely filled d subshell, 3D superscript 1, so no d transitions occur, no absorption in the visible region, complexes are colorless. B. Why Fe+++ is more stable than Fe++? ANS, Fe superscript 3 has the electronic configuration 3D, which is half-filled and more stable due to symmetry and exchange energy. Fe superscript 2 is 3D, which is less stable. Hence, Fe superscript 2 easily loses one electron to form the more stable Fe superscript 3. C. Sc+++, T++++, V+++++. Dot complexes are while even though all are transitional element give reason. ANS. These ions have no electrons in their d orbitals, d configuration. Since d transitions are not possible, they do not absorb visible light, their compounds appear white or colorless. D. What is transition metal? Why are they called so? ANS. A transition metal is an element whose atom or common ion has a partially filled d orbital. They are called transition metals because they lie between the s block and p block elements in the periodic table and show properties intermediate between them. E. What is the composition of stainless steel? Write its one use. ANS. Stainless steel is an alloy mainly composed of iron, Fe, chromium, Cr, 10–18%, nickel, Ni, often present. Small amount of carbon. It is used to make kitchen utensils, also surgical instruments, cutlery, etc., because it is corrosion resistant. F. Freshly prepared ferrous sulfate should be used while it is used as a laboratory reagent. Y. ANS. Ferrous sulfate, FeSO4, contains Fe superscript 2 ions, which are easily oxidized to Fe superscript 3 on exposure to air. If it is not fresh, some Fe superscript 2 converts to Fe superscript 3, affecting the accuracy of reactions. Hence, it should be used freshly prepared.